Editorial for binary prefix divisible by 5, today's Leetcode problem of the day. So what the question says is you are given a binary array nums, which is a zero indexed array. We define xi as the number whose binary representation is the subarray nums 0 to I from most significant bit to least significant bit. Basically, like you're given a binary array. So okay, let's say the binary array is 0, 1, 1, 2. Sorry, 2, and this won't be there because this is a binary array. So 1 0, right? So what would be our x0 here? X0 is that what is the binary, like this is the binary representation, what is the numerical value of this? So this 0, this would be 0 1, that is 1. This is 0 1 1, that is 3. This is 0 triple 1, that is what's triple 1? So that would be 1 plus 2 plus 4, that is 7, right? 7. Similarly here it would be 14, right? So that is this number, that is 2 plus 4 plus 8, that is 14, right? So this makes sense. Okay, let's erase this. Now what the question then asks us is, uh, for example, yeah, there is an example given here, 101. So x0 would be 1 because this is the binary representation. X1 would be 10, so that is 2. X2 would be 101, that is 5. Return an array of booleans answer where answer I is true if xi is divisible by 5. So basically for this array, we need to find a boolean, that is our answer. Now this answer would be true if this, like this xi value is divisible by 0, but is divisible by 5. If it is not divisible by 5, it would be false. So here the values are 0, 1, 3, 7, 14. So this, the first one would be true because 0 is divisible by 5, the rest all would be false. False, false, false. Right. So this is a easy problem, but I would say it is a bit of a harder of the easy problems, or like a bit harder than a normal easy problem, because the constraints are that num size is can be as long as num size length can be as big as 1e5. So why I'm saying that this is a bit harder than is that you can't actually like so what your logic, first logic would be that let's just generate these numbers, like, so how can you do that generation number logic is, let's say we initialize our x. Okay, we initialize our x as 0. Now when we encounter our bit, like, so how do we do this if it was not binary and actually digits? So if it was given us that these are the digits, how would you have done it? It's that you first get your first digit, then whenever you encounter a next digit, what you do is into 10 plus the digit, right? So whatever x, so x would be 10x plus the new digit, right? This is for base 10. This is for base 10. Now we are doing it in base 2. So this would just change into x equals to 2x plus the new digit. So what I mean by here is we initialize x as 0. Then here, because because the new digit is 0, so x would become 2 times 0 plus 1. 2 times 0 plus 0, so x remains 0. X remains 0. Then here, basically what is happening, we are adding one bit here, right? So 0 was the original binary representation, now we added 1 here. So now it would become x is 0, so 2 times 0 plus 1, that is 1. Here it would be 2 times the old x, that is 1 plus 1, so that is 3. And we can also see it is getting matched also. Here it would be 2 times 3, the older value, plus 1, that is 7. Okay. So you can do this, and then for each check if it is divisible by 5. The only thing that you need to make sure is, see, if it would have been that num size is very less, like it is around 30, then the maximum value could be 2 raised to power 30, so we can keep this in integers. But the thing is that it is very large, like it is 1e5. So the maximum value of this x could go as big as 2 raised to power 1e5. If you don't know what 1e5 is basically 10 raised to power 5. So this is just a easy way to state that 1e5 is 10 raised to power 5. Okay. So this is a very large number. We cannot keep it in int. We cannot keep it in long. You can keep it in string, but that is like if you keep it in string, the problem with that is how will you do the modulo operation. So there's a cool modulo property here. Let's see. X, so let's say our new x is what? 2 times old x plus 1 plus d, right? Now we are interested in only new x mod 5 because we need to check that is this divisible by 5. What is this? This is nothing but 2x plus d mod 5, right? So we can say that this is 2x mod 5 plus d mod 5. So what I'm basically trying to say is rather than keeping the whole number, we can only keep its modulo 5, and this modulo 5 would be in between 0, 1, 2, 3, and 4. So then it won't like we don't need to actually with the number won't get become very large. So this is what I'm basically saying, that rather than keeping the whole value, let's keep it only till modulo 5. Hopefully this makes sense. Let's jump to the code. This is why I would say that this constraint, that num size length can be a big, like can be big around 25. So that is why I would say that this is a bit harder, but it's still an easy problem. So let's jump to the code. Let me live code it. So one sec here. Let me remove this. What do we need to do is just create this. Okay. And then equals to nums dot size. We'll create our x, which is just the current value. We'll create an answer boolean array of size n. We'll go to I equals to 0, I is less than n, I plus plus. Now our x would become, as we saw, 2 times x plus num size if x mod 5 becomes 0. And this operation we can do modulo 5 only. So this mod 5, and this, because we can doing mod 5, this we can directly check it, because see, now this x could be 0, 1, 2, 3, 4. If it is divisible by 5, it will be 0. So if x equals to 0, we'll mark this answer I equals to true, else answer I would be false. Answer I would be false. Let me return answer and let's see if this works. Yeah, it works. Let me submit it. 1, 2, 3, 4, and yeah, it works. Thank you for watching. If you like this, you can subscribe, all of those things. Bye bye.